Hi and welcome to another video on reduce CO2. Now, I'm Thomas and today we are looking at CO2 scenarios. And it's like you have to understand that we are looking at CO2 emission scenarios. So how much CO2 is emitted in the world. And to understand this, we really have to look back in time. How much CO2 we actually were producing. And the measurement unit is gigatons, so it's billions of tons. And like here in the Second World War, it was around 5 gigatons per year. And this is only here from fossil fuel. There's also land use change, but and that means we are burning forests and these kind of things. But let's just look at the fossil fuels, and there was around the 5 gigatons. And then we started to, the world was ramping up production of things and stuff and so on. And it goes, you see this curve, this guy going up all the time. This blip here is by COVID. And today we are like 37 gigatons. And on top of this comes land use change. So we arrive at overall 41 gigatons produced in 2024. So you see this diagram is always going up. This means like the CO2 production of how much we actually emit into the atmosphere by humans is increasing all the time. So now the people have asked, okay, how is this going on? Because we want to predict somehow our climate and the global warming and these kind of things. So how much is this going on? Well, then let's look at, they developed certain scenarios. And again, like this curve is the one you have seen. The black one is the historic times. And this is like the CO2 production. It's like the same diagram like I showed you. But this is only here showing from 1950. And so you see the levels here are like around the 40. Yeah. So, and now the question is, what's going to happen now? And then, some scientists have come up with some scenarios. And they said, the blue and death scenario are the world is understanding we really have to do something against CO2 and global warming and stuff like this. And we are going to change immediately, rapidly and stuff. The only problem is that this diagram is already outdated because we are already here. And these blue scenarios that the world is turning around and changing and using much less fossil fuels overall. No, not going to happen. We don't see any of this. So then let's look at the other side. The other side, this is like the absolute worst case scenario where they thought, that we are, burning and burning and burning even more fossil fuels all the time. The world is getting more and more energy rich. All the energy, we want to use all this energy and we're using it and so on. So that's like the absolute worst case scenario, that we increase the production of fossil fuels. We are using more gas, we are using more oil, we are using more coal and so on. And there's even more people coming. And all these people, they want to have the same wealth and luxury and living standards as in the Western world, for example in the United States, where it's one of the producers most CO2 per person. So if the whole world would consume, we would be somewhere there. Okay, but this is the scenario where we are increasing even the production rate. This graph here, which was going up like this, it's even going to steeper. So you might say, hey, and this curve people think we are running out of fossil fuel. No, that's not going to happen. There's more than enough fossil fuels here to even sustain this for longer. Yeah, it's just a question of how to dig them up. But that's one of the most extreme scenarios, saying, hey, we are burning like crazy. And you might say, hey, that's maybe a little bit exaggerated, because already nowadays things like solar power are becoming the least expensive source of producing energy and so on. Yeah? So that's a curve. You might say it's exaggerated, but the red line here is the curve which is basically saying, hey, the same trend as today we are going to follow through. I think that's a quite likely curve, because there's still lots and lots of fossil fuels. They are sort of cheap to get, like coal. In a lot of places you just dig it from the ground and ship it somewhere, so you can sell it quite cheap. Also, the largest oil reserve in the world are in places where it's quite inexpensive to get them, like in Saudi Arabia and so on. They have the lowest production costs. So even, if people would say, if we use more electric cars and these kind of things, the cost for this stuff is just going down. And then, it's still getting produced because people can produce it and make a lot of money with it. It's a big money factor. And, a lot of countries are getting really rich. So are they going to stop? If nobody's going to force them? No, because in some countries, the whole income is just based basically on selling fossil fuels. So, to achieve, if you want to have this, if all the countries, if like the 20 biggest countries or biggest producers would just agree, hey, we are just reducing the amount of CO2 by the amount we are throttling down something like OPEC++, we are just throttling down production. That's fairly easy. Just 20 countries have to agree. But they didn't. They just made it, the producers are going to decide. Well, anyway, so this is like the scenario where we are going to burn, but we are going to increase. This is like the scenario where accelerating the increase of the production. Okay, and you might say, hey, that's maybe not so likely. Yeah, okay, so that's like the most extreme one, but this is like the current trend just extrapolated. And then we have an interesting here where we say, hey, for the next 10 to 20 years, we are still doing the same, but then we're going to reduce. There's actually not really much where it says, hey, we are going to start something like we are going to turn around. It would be somewhere here, but this is a very clever scenario because you don't have to do anything right now. It's in 10 years, in 20 years, it's going to decline. So you can still burn more and still say we are on a good track because the maximum is only in the future. Yeah. This is I nearly started to work for a company where the guy who owned the company or started it, he always said the aircraft is going to fly in 5 years or 4 years or something. It was cargo lifter. He was always saying it's going to fly in 4 years. And he said that at the beginning of the development, in the middle of the development, and then when he was bankrupt. He was always saying it's going to fly in 4 years. It was always, this target, this milestone was always running in the future. And this is the problem I have with this scenario, because you don't really have to do anything. It's we just do business as usual, do a little bit, and then technology or something is going to help us in the future. We don't have to do something right now. That's very nice. Politicians like this kind of scenario because it's it's a comfortable situation. You don't have to show any results today because you can still say, we are still on this kind of track. That's it. So these are the scenarios. There's the production scenario, and this is you see it doesn't happen. It's not going down drastically. This scenario is out of the door. It's not happening. And this scenario, you are extrapolating, we are going up, but then something is happening. Here's what's going to be business as usual, and that might be sort of extreme. So, and these are the scenarios. So let's say the blue ones are out of the door already. We don't see this. There are billions of people in the world who are living in quite poor conditions, and they also want to have some standard of living, So and this thing might be, restricted by the way we are producing. But, that kind of scenario, the red one, is sort of likely. And I think this yellow amber one is also just a distraction. They're always saying it's going to happen like this. But we will see. Now the question is, these are the scenarios, and they have been developed, and people calculated them, and they said, okay, we are going to come out on how much gigatons per year we are producing. Now the question is, what kind of CO2 concentrations do we have? Because again here, historic, this is already an outdated stuff. It's already here. We are at 425. This is around 400, so we are already higher. And we follow somewhere, around the red line. We don't see anything from this line here. And you see that line was like the most extreme. Okay, we forget that one. So, if I would like choose anything, I would say, hey, yeah, we are probably going to arrive somewhere between the yellow and the red. And the yellow is maybe a little bit optimistic with what we see today, with all the mechanisms in the world going to happen. So what we see here, well, we could agree like somewhere between here are the most likely cases. These ones, no, we are not seeing any evidence that something like this is going to happen. So if you are really optimistic, you are arriving here, and you are like a little bit pessimistic like me, you are like here. But let's agree somewhere in the middle is quite all right, right? And we are not going to arrive there. Now the question is, and this is like until the year 2100, where are we going to arrive in the sense of how high are we? So what we do is we go to 2100 and we go to the side, and then we can read here how much CO2 is going to be in the air. And so in the really nice scenario, we are going to arrive at 600. So remember, 600. In the I say more likely scenario, we are going to arrive at 800 something. Yeah? So if we take like 600 and 840 or something like this, we divide this by 2 and come to the middle, we are in 720. Okay, so we are somewhere between 600, 800, let's say 700 something is like where we could be at the end of the century in the CO2 concentration. Good, huh? So this is like the prediction. We have already 425. Like every year more than 3 parts per million are coming on top. And now the only question is, if we arrive at the end of the century at something like 600, 700, 800 parts per million, what would be the temperatures? Is this going to be 1 degree, 1.5 degree, 2 degrees or something like this? Well, predicting the future with any kind of certainty is really problematic. And that's why I show you another diagram, and I just say, for me, if I want to tell and explain somebody the future development of all these models, it's really so complicated to make a model and model the climate and what kind of temperature we are going to. It's so complicated. A normal person who has a PhD in climate science is probably really not going to understand it, fully grasp it. So I think it's too complicated if we ever work with all these models. Yeah, it's because in the sense you have to really trust the person who's doing this model, that person is doing it correctly, and usually they come with what they're modeling, but it's like supercomputers doing their work, trying to model out where we are going to be. But now we have like a prediction, if in the good scenario, like the yellow one, in the good one, we are arriving at something like 600, and in the more likely, I think, is like we are rolling to like 800 something. But let's agree that 720 is like a nice figure. It's like a compromise, right? So 720. What is 720 CO2 level on the planet compared to prehistoric times? Because that's like one cool thing here. We have figures of CO2 concentrations in the past where, scientists have been doing their work and found out that, how high the CO2 concentrations have been. And they were always going, this is like millions of years. This is 65 million years. And now what you can do is you can look up, okay, if you the levels we are today, this dashed line is, we are like 13, 14 million years ago. That kind of CO2 levels have been there. And there are certain temperatures here which are like 4 or 5 degrees higher than pre-industrialization. But we are going to 600, 720, 840, something like this. The nice thing why it shows 720 is because there's a 720 mark on this diagram here. And, this is 480, 720. You go here and you're going to cross the line there. Yeah? And this is like 33 million years ago. That's a nice, because there's like a nice dash here, and you see how it doesn't really matter so much if it's like 600, 700 or 800. You're going to cross the line somewhere there. And that time is associated with temperatures 5, 6, 7 degrees warmer. Huh? So it's that area. So it's really like, okay, we cross here, are we going to stay there? Or it's going to be, the real thing is, if you look at this, it's going to tell us, oh, we are going to arrive at least in this 5, 6 or 7 degrees more area, no? So it's really like, are we like 4.5 degrees, are we 5 degrees, or are we 6 degrees, compared, or 7, it really doesn't really make much of a difference. We are going to arrive somewhere here. We're there with these blue temperatures. We're going there. This is like how I can try to explain somebody. We are going to very high CO2 concentrations, 600, 700, 800 parts per million. This is like the prediction of what we see today with the current trends. And these kinds of concentrations of CO2 are associated in prehistoric times, something like 13 million years ago, and the temperatures on the planet with these CO2 concentrations have been at least like 4, 5, 6 degrees higher than pre-industrialization. So staying anywhere near 2 degrees is really out the door if you look at this. So thank you very much for watching. Please follow the channel. We really have to do something about this, and you can like, subscribe, and of course, leave a comment what you think of this. And thank you very much for watching.